right, welcome everybody. My name is Jay Wargacki. I'm the operations manager here at the Excellence Training Center. Where you're standing right now used to be the misdemeanor jail for Mahoning County, but we converted this entire facility into a manufacturing training center. Basically, we do everything from start to finish. We have a design lab to my right, where we teach basic CAD softwares, AutoCAD. We use SolidWorks, Fusion 360, and for more organic, we use Mesh Mixer, and we have haptic pens for Geosculpt. Basically, you start with a design. From there, we go to a different manufacturing process, and that's everything else we're going to see in this building. All right, keep going this way. All right, so this is our design lab. We do a little bit of everything from art design. We use Adobe Photoshop systems based off what we're going to end up making. It could be artwork. It could be digital clay. So in this lab, we have haptic devices that allow us to physically, digitally sculpt. I can actually feel that and follow the different structure that I've formed. So by utilizing this, I can actually burn it away, melt away, add material. Very hands-on, but actually I can feel all that. If I leave it in the space, my pen hangs in space. So it's just more organic, more visual, instead of the traditional CAD, which we also do in here. So it's SolidWorks, Fusion 360, AutoCAD are all different softwares we utilize. All right, follow me this way. I'll show you our traditional manufacturing lab or subtractive lab. All right. To my right, we have manual milling machines, a variety of different systems and brands from different OEMs. On this side, we have our manual lathe section as well. And in addition to that, we have our drill presses for standard subtractive stock removal. Follow me this way. I'll show you some of the samples and reasons why we use all this still today. On my left, we have our saw cutting areas. Basic concept, in order to make something like this, lighthouse and waves, we start out with a material like this. The round stock is what's used in a lathe usually, and then a flat stock is used for the mills. Then we subtractively move the dials, and we use end mills to actually spin and cut the material away to form our part. If you look on the table here, we can take everything from a 3D scan to a machine surface. Now this isn't done on a manual side. We actually use a CNC, computer numeric controlled. Behind me here is our CNC lab. We have a variety of mills and lathes, but we program those either at the screens or through a different CAM program, computer aided machining program, such as Fusion 360 or Mastercam that we utilize in this facility. Allows us to do more intense geometries. But as you can see, everything in the world starts with something that needs to be machined. Stuff you never even see, like inside of an orange juice machine at McDonald's. You have a variety of components, keys. You want to know how Legos are made? It's all through injection mold tools. In order to do these, very precise. Do high-end precise machining of electrodes out of graphite to actually use electric discharge machining process to burn away the cavity components to actually make the geometries that will later be used to make the plastic parts. It could be also used for, a printing press or a hairspray or a cap for spray paint from a mold, things like that. And you saw engine components, carburetor components, chest pieces, trophies, whatever you need to make. And now you might wonder, a lot of people wonder, why do we need it if we can 3D print? Well, if you look at this component here that was 3D printed, it's great to get these geometries, but you still need to be able to machine them off the metal plate, and you need to finish them because it's how it's formed. So these traditional methods are used every day, and they're also still more precise than most additive manufacturing methods. All right, here to my left is our inspection lab, also our layout lab, where you start before you start machining, you actually lay out your parts and your components. Follow me in here. I'll show you some of the other equipment that we have. So basically, when you start machining, you have a visual representation. So we use Dicom, and we do layout lines with scribers. That tells you measurements. So when you actually touch off on the steel with an end mill or a tool bit, you actually see where you're going to cut. Over here, we have different micrometers, verniers. We have a variety of dial indicators, different scales. And basically, these are the tools that are used to lay out and then later inspect your part after you've made them to make sure you're to the proper dimension of what your design requires. And then around the room, we have a hardness tester, some more indicators, and a variety of gauges from pin gauges, bolt gauges, things along those lines. Traditional subtractive processes, and these are the tools related to those. All right, so that's for the standard. The next room is our metrology lab. Our metrology lab, we're looking at a little more higher end equipment. Follow me this way. All right, so in this room, we're actually inspecting with other pieces of equipment. In this room, we have a variety of other hardness testers. We have a polisher that we actually use to make samples that we'll analyze, whether it's on the hardness tester or our CT scanner. We have some microscopes. We also have laser profilometer, so we look at surface finish, things along those lines. We have a variety of 3D scanners in this facility. We even have high-speed cameras to analyze the actual processes that we're inspecting. That's what we have in here, and everything in here is pretty much check the outside of the part. We also check, we have heat sensors, things along those lines, and then we're going to go in here. Our next room is actually our CT scanner. We're going to see inside of parts. Follow me this way. This is our CT scanner. Basically, we put our components inside, we mount it, and we blast it with x-rays. We blast it with x-rays, we can look inside of the part to see if there's any fractures, if there's any porosity, or any cracking, things like that, that we can't see from the outside with a basic microscope. We also have some digital microscopes in here for analyzing different materials and surface finish. We also have thermomechanical analyzer to look at different substructures of the materials of the materials we're running. And then we also have a loaner room arm system from Hometown Products that we also 3D scan and inspect parts with. That's what we have in here. So pretty much just additional metrology inspection tools and ways to see inside the part without destroying the part in question. All right, follow me this way. All right, next we're going to show our research area, our advanced CNC, and our foundry. So follow me this way. All right, so this area is primarily used for research. We have two main projects going on currently. One is for the Air Force. Over this side, you see the Mazak machine with Lincoln Electric. That is a hybrid system. It uses a process called direct energy deposition. So actually, it's a laser welder. So basically, a Lincoln Electric partner with Mazak. The Mazak side is a 5-axis subtractive CNC machine that actually removes material, just like the other CNC lab. The Lincoln Electric uses a wire-fed system that actually builds up. So you look at some of these components here, it's weld built up, but we can actually subtractively machine material away from it as well. The end goal for the Air Force project is to use this for quick repairs and cheap repairs, hopefully, for spare parts and spare components. So we have that going on this side. Behind you here, I'll show you in a minute, if you look at this table, we have our foundry set up. So traditionally in foundry world, we have wooden patterns, but we've advanced it. We actually utilize 3D printing to make some of our components to actually end up make a full metal component like the Zax blade here. We can actually 3D print wax now with some of our other equipment that's in the facility. We use a slurry and we can actually melt it away and fill the mold that way. With our partners at Hometown, they run our 3D printer, our sand printer. So behind you here, these are 3D printed sand molds. So we can melt down our metal and pour them directly into the sand now as well. So we can make different components based on what the needs are. Now, when you pour a sand mold, when you're done with it, you actually have to clean it up. It looks something like this. It's kind of rough. You have these pour spouts and you have all flashing to clean up. But basic concept, right behind you here, I'm sorry. Out of the mold, you're gonna have something that's untrimmed and unmachined. So you have a lot of excess flash, extra material that you need to get rid of. But the foundry room, which I'll show you in a minute, basically gets it to this state. The next room here is going to be automated to actually take it from this state to this state, where we're trimming off the excess flash and we're adding some of the features that need to be done. And then eventually you go to the machining side, you actually finish it to the actual spec, final part. That's what's happening here. So basically this untrimmed, unmachined, straight out of the mold from that foundry. And then we have the post-processing finishing lab, and then we have the full machine components as well. We'll walk around this way so you can see some of that. We'll start in the foundry. So here, part of this project We're using an automated system. We're using a FANUC system to actually, we have two ovens here. I'm gonna take it back. We have a crucible in the drop-down furnace. We have a tilt furnace. The robot actually will take the crucible out of the drop-down furnace, bring it over here to a turntable where we place our sand molds. There's a couple examples of sand molds here. And the robot will actually pour it in safely so all the people are out of the way. So you have the sensors set up so it knows where to locate, how much to pour, things along those lines. And we also have digital twinning occurring based off all the sensor readings that we're receiving from the setup. But once the sand mold's full, you break it apart, and this mold right here that you see, actually you see a sample of the metal on the back here on this table. Basically, that sand mold would create something along one of these lines, one of these designs. This, as you can tell, it still has all the molten metal that's been poured. This is all aluminum. But basically, these all need to be cut off and machined away. You can see some of the excess flash. You see the core. So the core right here was 3D printed. That was inside of here. And basically, we need to be able to get rid of all this excess flash and the extra material. And that will be done in the next room over here. This is still being set up, but should be operational soon. We have another FANUC robot here. We have an AIDA press that will be using a shearing die to cut off large chunks of material. We also have a bandsaw, and we also have a sanding station. Basically, the automated system through a camera up here to your left will be able to analyze the material, what the part is, and how to grab it, how to get a hold of it, and take it to the different stations as needed. Every component is going to require different programming, but that's what we have going on in this space. We also have post-processing equipment in here. So beyond the automated systems, we have manual systems. So we have a bead blaster to take off excess flash, clean off sand out of the actual component that's been poured. We have heat treat ovens, quench tanks, sand mixers, and then we also have a variety of ovens, heat treat ovens, additional ovens. So we use these guys to actually heat treat some of the materials that we're running. We have additional furnaces for some of our 3D printed metals as well, which I'll talk about in a little bit. That's what's done in this room here. All right, we got in this space. All right, we're gonna head over and cut through our industrial maintenance lab. So follow me this way. So industrial maintenance is a generic term for anything you're gonna see in industry. It could be everything from rigging, so how to move heavy objects, how to properly support them, how to rig them so everyone is safe. We have different systems, weight systems, but we have training modules associated with these different topics. So rigging is one of many industrial maintenance components. We go in this lab, we'll have a class going on, but you'll see everything from electronics, shaft alignments, motor controls, hydraulics, pneumatics, piping, even how to use basic hand tools. So we walk in here. You can just zoom around and see some of the equipment modules. But basically, different classes. We have industry training. We have YSU classes in here, utilizing these different systems to learn how to operate and maintain these different pieces of equipment that they're associated with. All right, follow me back here. I'll show you our wood shop. This helps support our traditional foundry builds. But we also have a CNC router back here that we can make a variety of items with and cut a variety of different materials, not just wood. As you see back here, we have some sanding systems, jigsaw, table saw, a band saw. Here's our CNC routers, Laguna based. With this, we can program through Fusion 360 or Aspire software. There's different components to it. Everything starts either with an art file, and then we create a CAM file for it to actually control the machine, just like we would in the CNC machine shop. On the table here are a couple samples, just so you can see what we can make. Different woods have different hardnesses, and we have to play around with the settings on the machines. We can actually even do epoxies that we machined, filled in, recoated, things along those lines. So basically, it's whatever you want to make, we find a way to make it here. Next is our newest room in the facility. This is our laser powered bed fusion room. We have two exact laser powered bed fusion systems. I'll show you what those look like and some samples off the parts. Take a look. There's nothing running at this one right now at the moment. Basically, laser powder fusion takes a metal powder, spreads it to the right-hand side, there's a build plate on this side, and a laser turns on and melts that powder to the actual build plate. It then lowers, spreads a new layer of powder, and does the next one. So on and so forth, it builds up. You suck out the loose powder, but everything that is sintered looks like the stuff here on the table. So these are solid dents. You control all of that with your slicer settings. There's just a variety of things. We're still learning to play with the systems. Something like this we'd use our CT scanner for. So you see these little holes here. There's actually different internal lines and ductwork inside of that you can't see, but we can see it with the X-ray system. So we're analyzing that. A lot of laser powder fusion allows us to lightweight components and redesign internal as well as external designs for different patterns and different purposes. That's what we have in this room. All right, welcome. This is our additive manufacturing lab. You saw our laser powder bed fusion additive lab already. In this lab, we're running 3 different families of additive manufacturing. We're running material jetting, which allows us to 3D print wax. We also have material extrusion, which is kind of a standard desktop printers. And we also have vat photopolymerization, which uses a light source to cure resin. That resin allows us to get finer detail. If you look on the sample shelves here, this shelf here is showing some samples from vat photopolymerization. We have some samples from material jetting. This purple stuff here is wax. A variety of different materials and flexibilities based off the actual resins that are used in the system. Binder jetting is another family. Our partners at Youngstown will allow us to print sand, which we use heavily in our foundry. Binder jetting can also be used for metal and ceramic powders on top of that. Over here on this shelf, you'll see some samples of material extrusion. So we're definitely fans of Star Wars and other fun stuff here. We have powder bed fusion, which you saw in the other room, but these are some samples from other machines, other systems. As you see, it goes on a build plate and needs to be machined off the build plate. The Mazak you saw earlier in the tour, you'll see direct energy deposition, basically 3D printed weld that needs to be machined down. We also have powder-based hybrid systems that are powder deposition that can also be machined on top of that. And then we have sheet lamination is a 7th family that shows that you can layer paper or the product layer by layer. So we have in here. All right, follow me this way. Next, we're going to show you our laser cutting lab. We currently have 2 systems in this facility. We have a Boss laser and a Zing. Basically, we use different software, and we use everything from Photoshop to Corel Draw to generate the pathway that the machine will follow to actually cut through the material or etch the material. There's only certain capabilities that we can do, but we can etch glass, metals if it's coated, different woods, acrylics. It's a wide variety. You can make 3-dimensional objects, magnets, you name it. Do a little bit of everything in this space. So whatever you design, we figure out a way to make it. We actually have software that can take a 3D model and cut every single layer out to produce a 3D model as well. And then on this side of the room, on loan, we have virtual reality welding trainers. So we have headsets, and these systems allow us to do MIG and stick welding, different geometries, and there's different setups for different materials to learn how to do that process. That's what we have in here. All right, next is our PLC lab. It's our Rockwell automation lab. Doesn't look much now, we have new equipment coming, but basically these are Allen Bradley systems. Rockwell Automation has their own curriculum associated with these. We do classes for our students as well as industry individuals to learn how to run these systems. In addition to that, we have some FANUC handheld trainers, which I'll show you in a little bit. We actually turn these computers into digital robots as well. That's what we have in here. All right, heading down the hall. One part of manufacturing is post-processing. A lot of people don't talk about it, but it can be everything from heat treating to actually polishing, grinding, and finishing. So this space here is actually used to finish the component to the final design. And we actually inspect in here as well. All right, welcome to our robotics lab. As you see to my right, we have some universal robots. This is one brand of robots. They're very user-friendly. We're currently setting up some of our conveyor belts for these systems to offer more additional training classes. We have a larger unit over here wielding a lightsaber, as you can see. Pre-programmed, but if you notice on this guy here, we have a different color on this other side. And these are called co-robots. So notice there's no fences around these. If I put my hand out to stop this, the machine will actually stop eventually. So it's a safety mechanism built into these. So some systems have sensors like these guys inside of the machine to stop. Other ones have gates around them, which I'll show you, and you saw some of the other labs as well. We go around this side, we'll talk about the FANUC robots. We have different certifications we teach for the FANUC robots. We have a variety. We have a Delta system with a vision thing on it that can actually separate different pills, the red pills and white pills. It can separate them with the vision. This guy here can actually coordinate and rotate the die and see which side they're picking up on. We have this FANUC CR35 here. We actually have a 3D scanner mounted in it right now. We're actually automating 3D scanning of different components for part of our research project. And then we have a work cell here using 5 different systems. The basic concept is FANUC offers 3 different certifications that we can run here. One is tool handling, which allows us to learn how to program the robot and how to move it around properly. The second certification is IR vision with camera systems involved. And the third is integration with a PLC, or programmable logic controller. The PLC is the brains and guts to any of these systems, so these can interact together based off sensors that are on the conveyor belts or on the robots themselves. A few different systems, some PLC samples over here on the red carts. You got some PLCs on there, and then we also had the Rockwell Automation Lab downstairs and a few other systems for training. This lab here, basic automations can be used for everything from any situation where it's repetitive motion, or it can be a dangerous situation like our foundry. There are a lot of applications. We also have some other units, 200s. Basically, there's different sensors on these. As you see, this has a cage around it. It has no sensors built in, so it's not a collaborative robot. So it has to be protected inside of there. And then we have an open one over on this side of the room. This guy here has a set area sensor. When you get closer, it'll actually slow down. If I pass this light barrier here, you have a red, orange, and green system on the back, and that tells you when it's actually going to stop. So it'll actually stop by so it won't hurt you. So a lot of different systems in play. That green one there has like a Nerf body that's pushy and squishy that it actually will stop and slap it. It'll stop moving for safety purposes. That's what we have in this lab.